everyone, I'm Haley. I'm one of your lab IAs, and today I'm going to be showing you how to analyze Lab 3.1's data. So that's our Wettability lab. So first, you're going to start by downloading image J and opening it. And then you're going to go to File, Open, and pick the file you want. This is the data that Dr. Burns had collected last semester. It has an extra material, so don't worry about the parafilm. You weren't supposed to test that. And then these are different brands, so the numbers might not be the exact same that you get, but this will show you how to accurately analyze everything. So one of the reasons I picked this one instead of my own data is because Dr. Burns had used a micropipette. So all of these are set 10 microliters, which will make it more accurate at the end when we're calculating the contact angle. So to start, we're going to pick the line tool and measure the distance of one of these squares. We're measuring that length right there. So there's a little bit of an issue. We want everything in pixels, and right now it's in inches. So just go to Analyze, Set Scale, click to remove scale, and everything should be good now. So now we have a length of 58.009, which is pretty close to what it should be, if not exactly what it should be. And then we're going to run it again, Analyze, Measure, Analyze, Measure. So we're going to be plugging these values into a Google Sheet that will be provided to you. And then we can analyze the droplets now. So for each of the slides, we're going to randomly select 3 different droplets and test them 3 different times. So you can put that as one of your randomization steps in your abstract. And so you're going to want to pick the oval tool, and I'm going to randomly select this one on the scratch glass. So I'm going to measure this one 3 times. And you want to try and encompass the entire area as best as you can. So analyze, measure, and now do it again. And again, you're trying to get it as close as possible without overdoing it. And then one last time. Okay, so now you can see we're going to be taking the area, so 2732, 2786, 2632. That's around what it should be. And then I'm going to randomly select this one for the PDMS. So there we go, that droplet, measure. And then I have this droplet again. And this makes sense because you can see that the scratch glass droplets are far bigger. So the area being bigger for the pixels does make sense theoretically. And then this. Okay, so it got a little bit big at the end. I might have overdone it a little bit, but I can't really tell. It will all even out by the time you're done averaging. So here's the Google Sheet I was talking about. First, you want to calibrate. So our first square, we're going to the length, was 58 point. Oh, it's not typing. There we go. 58.009. 58.034, and then 58. So that's perfect. Now we have scratch glass. We did 1 droplet with 3 replicates. So you can also put that in your abstract. One of the things is replicates. So we have 2732, 2786, 2632, and then we're going to go down to PDMS. And this was 611, 535, and 711. And then you have these functions that are going to calculate it for you based off of your calibration above and the area that you have here. So now you can use the contact angle from the nomogram. So you're going to open up that file that was provided. And remember, one of the reasons why this one was so good was because we had a set volume of 10 microliters. So I'm going to take out my little annotation tool here so we don't accidentally read one of the other values. So for the scratch glass, it's 6.45, 6.51, 6.33. So that's around here. And so we're going to go down here to 26.1 and 20.8. And now we're going to guesstimate what the contact angle should be based off of these values. So this is 6.45, which is really close to 6.5. It might be a little bit bigger, so you might want to put like 20.9 or even like 21, but this should be about accurate. 6.51, you might want to go a little bit above 20 point, or a little below 20.8, I should say. But 20.8 is probably about accurate. And then 6.33, that's going to be like around halfway between, so you can say like 23. Well, a little more than halfway in between, so closer to 20.8, so maybe like 22.7. So that's how you find the contact angle there. And then for the other one, PDMS, you have 3.05, 2.85, 3.29. So again, you're going to be looking in that same spot. There we go. So you have 3.05 and 2. So around this area. Oh, yeah, even that one. So it's going to be around here. So as you can see, it's basically just going to be greater than 90 for all of these, which makes sense for the hydrophobicity wise, and then greater than 90. So then after you find all the different contact angles and average them, you put them into a graph like this, where you're going to show the significant difference between the different materials, and then you should be all good. So good luck, everyone. You guys are going to do fantastic.